Virgin West car.
Yes. Hey, Anna, how are you?
Good, how are you?
I'm doing good.
Okay, I had some questions about starting on number 12. I need some help, from there on.
Okay. All right, great. I had an email for number 14 on. So cool. We'll just start at 12 and kind of work our way through. Does that sound good?
Yes.
All right. And do I have the right worksheet pulled up? Is that the one you were talking about?
Yes, that's the one.
Okay. Just making sure. All right. To determine whether it's arithmetic or geometric when you already have the summation symbol there, just to make sure that you're understanding this piece of the puzzle, that I'm going to be drawing over on 12 and 13. If there's an exponent, that's going to be geometric. And if there's just a plain old letter in the formula, then that's going to be arithmetic. Does that make sense?
Yes.
To distinguish, I didn't know if you were already good on that part or not, so I just wanted to make sure, clarify all questions, I guess.
Okay, that makes sense.
Okay, so we know this is arithmetic, so we're going to use the arithmetic summation formula, which looks like this. So we're going to plug in what we know. And basically on this, what you always want to do is take that top number, subtract the bottom number. In this case, it's going to turn out to be 34 because the bottom number is 1. But I just want to remind everybody that's either on now or watching that this works every time, no matter what the top and the bottom number are, is that you take the top number, subtract the bottom number, and add 1. But in this case, it's just going to turn out to be 34 because the bottom number was 1. Okay. But that gets the n for you every time. And then the a sub 1 is the value of the first term, which then you would just substitute 1 in for the p. So that's going to be 19 minus 2 times 1, which would be 2. So that top value is 17.
Okay.
And then you're going to plug in 34. So 19 minus 68 is a negative 49.
Wait, why did you plug in 34 for the second one?
Because that is you're looking for the value of the 34th term. That's the last term, because you're looking for, this number up here was 34. So yeah, you're looking for the value of the 34th term, because that's what the a sub n means. And it's interesting. I used to, a long time ago, write this formula instead of a sub 1. I'd write it as a sub f for first term, because sometimes this term right here is a 2 or a 3 or a 4, but that would be the first term. So I would do a sub f plus a sub l, which would be the last term or the final term that you're looking for the sum of. Does that make sense?
Yes.
That's how I used to write it a long time ago, but most of the textbooks, and I didn't want to confuse students, but most of the textbooks all write it a sub 1 plus a sub n, or if you look it up on the internet, that's what you're going to find as well. But I used to do it like this because you're looking for the value of that first term, which is the bottom. So if that was p sub 2, you would plug in a 2, or if it was p equals 4, you would plug in a 4. It's the number of the term, and then that would be the value, but you plug in that there. Does that make sense?
Yes, that makes way more sense.
Okay. And so then the a sub l is the last term, or whatever the number of the top one is. It's the value of that. So you would plug in quote unquote, where it is in the sequence. Like if it's the 4th term or the 5th term or 6th term or the 34th term in this case, that's what these are. So I don't know if that helps distinguish the difference or not.
Yeah, that makes sense.
Okay. So I've got a plus, negative 49, or I could have just written 17 minus 49. But I just wanted to make sure you distinguish that you're plugging in the value of the 34th term there. All over 2. Like that. So then it's just calculator work, really. 17 minus 49 divided by 2. That's negative 16 times 34. So you should get negative 554.
Okay.
And so this one, we would plug in a 1 for the n. So that's going to be 1 for that first term. Let me write down, I'm sorry, let me write down the formula first. We know it's geometric. Oops, I don't want to write it there.
Are we going to be allowed to use that sheet you gave us on Monday on the test?
That's what I'm hoping. It's either that or I'm going to give you the formulas.
Okay.
But then that means y'all would have to be able to distinguish the formulas. Would y'all be okay with that? If I just gave the formulas?
Hopefully.
Okay. But I'm trying very hard to match Miss Wynn's class also,
Mm-hmm.
and so that the classes aren't that different. So we're talking to Miss Stone also, about what she wants, as the department head. So that's kind of where I am. I'm kind of in a holding pattern. So hopefully I'll have a good answer for you guys in class tomorrow.
Okay.
Or a solid answer. All right. So we're looking for the value of the first term. So you would plug in that 1, like I was saying, for that n, and that would make right here, that would make this 4 to the 0 power, which we know that to always be 1. And so 1 times a negative 1/8 is negative 1/8. And then the formula, we just plug in 1 minus, and then the common ratio is here in the formula. When you're looking at that formula, it's the base number to the exponent. So my common ratio is 4. And once again, you kind of figure out your n for the power in this formula. You figure out the n by taking the top number minus the bottom number, which would give you 6, plus 1 equals 7. And for this case, it obviously worked out fine because this bottom number is 7. But I go through this process every time because when this bottom number isn't a 1, obviously you would get a different number, and that would be your n.
Okay.
So n equals 7. So that's how you determine what your n is. Then we're going to close the parentheses, and then that's all going to be over 1 minus 4. And once again, this is just calculator work. And as long as you're really, really good with parentheses, you could actually do open parentheses, negative 1 divided by 8, close parentheses. Actually, I did that wrong because you'd have to have 2 open parentheses. So I think, yes. type in 2 parentheses,
Okay.
-1 divided by 8, close parentheses, and then open parentheses, 1 minus 4 raised to the 7th power, and then close parentheses, divided by -3, because 1 minus 4.
Okay. I got like -682 and then like a decimal.
Yes.
Okay.
And so let me hang on just 1 second. Is that what you got?
Yes.
Okay. And if somebody, is a fraction girl like myself, fraction guy like like I'm a fraction girl, the other answer would look like that.
Okay.
But either one is correct. You just have to be really, really careful with the parentheses things. You know what I'm saying?
Yes.
On that. Okay, so number 14. I appreciate you hanging out with me in math lab.
Thank you. And Bella's here. Do you have any questions, Bella?
Actually, I was just wondering because on the lesson plans it says the arithmetic versus geometric review, and I wasn't sure. Like, I couldn't find that worksheet in my stuff. So did you give that out to us yesterday?
Actually, that's homework number 5, and then that thing in class on Friday. So I probably just didn't label it well. I'm sorry, Bella.
Okay. Is that the one that said arithmetic, geometric, or neither?
Yes, ma'am.
Oh, okay. All right. I'm good then. Thank you.
No problem. I will fix the wording on that. Let me see. Let's see. Complete arithmetic versus geometric worksheet. So maybe I should put arithmetic, geometric, or neither.
Yeah, that's good.
Okay. If you did not finish it, and then complete homework number 5. So that's good.
Yeah, thank you so much.
Oh, no problem. No problem. Sorry about the confusion.
Oh, no, it's good.
Okay. Did you have any other questions?
No, I think I'm good for everything else.
Okay. All right, good.
Thanks.
Thanks for letting me know, Anna.
Oh, no
I
problem.
can't be on this worksheet and see what's going on in Google Classroom. Kind of a bummer.
Yeah.
But, okay, so number 14. I know this is geometric due to the fact that it has an exponent. So I'm going to use the geometric summation, which is a sub 1. 1 minus r raised to the n. I just have a tendency to always write these two just because it helps me remember what I'm looking for in the problem.
Yeah, I usually write the formula too.
So, and your handwriting's probably neater than mine as well. Because that 1 down there at the bottom almost looks like a 7. All right, so this is one of those where if you take the top and subtract the bottom, you get 8 plus 1 equals 9. So my n is going to be 9. So different than just that top number because you know that that bottom number is different. Does that make sense?
Yes.
All right. So I know my n is going to be 9. I'm going to take my 2 and substitute it in here. So 2 minus 1 is 1. So I'm going to have 640 times 1/2 for my first term. Well, half of 640 is 320. So that one I can do. That's not too bad of a fraction right there. I can actually handle cutting something in half sometimes. Depends upon the day.
Yeah.
And then 1 minus, then the common ratio is 1/2 raised to the 9th power, because that's my n, all over 1 minus 1/2. And once again, this is just calculator work using your parentheses very cautiously. So what I would do is, let's see. I actually would do open parentheses twice. How many do I have here? And then 1 oops, my bad. Clear. I apologize. Open parentheses twice, 320. Open parentheses 1 minus open parentheses 1 divided by 2, close parentheses, raised to the 9th power, and then close parentheses twice, right? Or once. Back over that last one.
Okay.
No. Yes. Yeah, actually, I'm sorry, do that again. And then divided by 1 minus, and you could actually do 0.5 here if you wanted to make that a little easier. And then equal. But I don't, somehow I didn't get the same answer as the answer sheet, so I don't know if I did my work wrong or not. So hold on just 1 second. If
Okay.
I may have to work it out via fraction.
What did the answer sheet say?
The answer sheet says 638.75. What did you get?
I got like 318.
So did I. So I don't know if we're right and she's wrong, because I've gotten a couple of these where she is wrong, but I don't either that or, so I'm going to take it one step at a time and work the whole thing out. Like 1 divided by 2 raised to the 9th power and start from there. You know what I mean?
Yeah.
And then 1 minus that times 320 equals divided by 0.5. I must have done something wrong with my brackets when I had us type in before, because when I typed it in one at a time, I got 320 times, and it was a huge decimal, and now I can't even find where it was. Divided by 1/2, and this was, I don't know what the decimal is. Let's see. It's like point. It's long. 998.
Okay,
04.
I got that.
You did? If I just put it in one step at a time, it went way better. You know what I mean?
Yes.
Hey, Brooke, would you do me a favor and call Momo back, please? I don't know. I don't have any idea. All right. So let me write down that answer, because I'm just sure I did something wrong with my brackets. And that's why I said Using the calculator is amazing, great, but you really have to make sure you use those brackets right. And I probably just didn't put enough in.
Yeah.
So sometimes, just to be on the safe side, you might want to do each individual piece by itself. You know what I mean?
Mm-hmm.
Like do that, the inner bracket here. I'll like do this part first and then multiply it by this part and then subtract this part and then divide it by this part.
Yeah.
Okay, on this next one, number 15, that's arithmetic. And I know that because there's no exponent. So the formula is S n sub n, and then the number in the sequence, A, and then that's the value of the first term that they're wanting, plus the value of the last term that they're looking for, all divided by 2. So the n is 29 minus 1 equals 28 plus 1 equals 29. And we knew that because the top term was 29 and the bottom was 1. But I just like to re-emphasize that you have to double check. So the number of terms is 29. And the value of the first term, you'll plug in a 1 for the k. So that's going to be 5 minus 42, which is negative 37.
Yes.
Plus, and then you're going to plug in 5 times 29 minus 42. And I get 103. Did you?
Yes, I did.
All over 2. Once again, a lot of calculator work. I got 33 times 29. Is that what you got?
I did it like steps differently, so
Oh, okay. No
let me
big
do
deal.
it one at a time. I think that'd be easier.
No big deal. So let's see. 33.
Yeah, that's what I got.
So you get 957?
No, I didn't. Wait,
29 times 33? Because you have to multiply it by that.
Oh, for some reason I added it.
Oh, okay.
Yeah, I got 957.
Okay. All right, so we're back to geometric. Excuse me. And I see that there's an infinity symbol on the top of the summation. So the first thing I want to do before I work anything out is I want to confirm that this is the absolute value of this number right here is less than 1. And it is because it's 1/5. So I know that this is going to be a convergent series. So my a convergent geometric series with a common ratio of 1/5. So that means I'm going to use the formula for a convergent series, which is S sub n equals the value of the first term over 1 minus the common ratio. So the value of the first term here is 250, because if you were to plug in a 1 for that m, that would give you a 0, and 1/5 to the 0 power is 1, and 1 times 250. But you always know that this number right here is the first thing. But I just wanted to kind of prove it by saying even if you went the long way of substituting that 1 in for m, you would still get that 250. Hopefully that makes sense.
So if there's like an infinity sign on top, you know it's going to be either convergent or divergent?
Correct.
Okay.
And so if this number right here, great clarification question, Anna. if this number right here is greater than 1, and there's an infinity symbol on the top, then you cannot do it. You couldn't find the sum.
Okay.
Okay. So more than likely on the test, something like that isn't going to be given. If there's an infinity symbol on the top, I'm looking for the fact that that's going to be less than 1. But I just kind of want to put that thought in y'all's mind, because if you take the ACT or SAT, I don't know how they would handle that. You know what I mean? They might try to give you a trick question and put 3 halves there, which is not less than 1, because that's 1.5. And so your answer would be, no sum can be found. So I guess, for test purposes in my class, I'm not going to play a trick on you, but, for ACT, SAT purposes, I can't promise that. Does that make sense?
Yes.
Okay, good. So you've got 250 over 1 minus 1/5. So that's actually going to be 250 over 4/5, which if you keep flip change, that's 250 times 5 over 4. Which then reduces to 3.12.5.
Okay.
Okay. All right. How are we doing? You feeling better about this?
Yes, it's making much more sense.
Oh, praise God. I'm going to move this over here to give myself some room to work for number 17. And keep the answer there for you. Okay, so once again, you see the infinity symbol at the top. So you want to confirm that the common ratio is, in fact, the absolute value is less than 1, and it is. So we will use the infinite sum series summation formula, which is the 1 minus r. Okay, so you're going to take the first term, which in this case is that -2. Once again, if you were unsure of what that was, you would just simply plug in a 1 for the y, and that would be 1 minus 1, which is 0, and -2/3 to the 0 power is 1. So if you're ever stuck on that part, you can always defer to plugging in a 1. And then the bottom is going to be 1 minus a -2/3, which then that would be -2 over, and that was going to be plus 2/3. So we would convert this 1 to 3 over 3. So 3 plus 2 is 5/3. Does that make sense?
Yes.
Okay. So then you would keep flip change. Which equals -6/5. That one was an easier, easier fraction to work with for sure.
Could you do it in decimal form if you didn't want to do the fraction?
Sure, you absolutely could. I think, what would that be? Like -1.2? Is that right? Okay.
Mhm.
Yeah, I can write that down there too, just in case. That doesn't look like a very good decimal, but okay. The football team is running a jackpot in which the prize will start at $2,500 for the first game and then increase by $500 each game if there is no winner. If there are no winners, find the value of the jackpot at the end of their 16-game season. So because it's increasing 500 each time, that's an actual common difference. So I know it's arithmetic. Does that make sense?
Yes.
Because you're just going up by the same amount each time. So the common difference is 500. And I know that I'm looking for the end amount, which is 16. So the first thing that I want to do I know that I've got a common difference of 500 and then n minus 1. And then I'm going to add the value of the first game because that's the first value, right?
Yes.
Okay. So and then this n right here is 16. Does that make sense?
Yes. I just always get like jumbled up on how to like set it up sometimes. So.
Okay. All right. Since this one, believe it or not, this one is kind of straightforward. So a lot of times if you weren't really sure of certain things, you might have to actually find the formula and then use the formula. But since you know so much on this one, like you know it's the 16th, term, you know exactly where it starts. So you know the a sub 1. Because if you think about it, it's going to go up. This is your first game. And so basically you're increasing by 515 more times.
Okay.
So all of this multiplied and added together is $10,000. Quite a jackpot. All right. The value of Casey's home for the first 3 years after purchasing is given in the table below. If this pattern continues, find the approximate value of his home after 30 years. So what we want to do is, I guess you would definitely want to see if it's geometric or arithmetic by, doing some of the tests that I talked about in class, like subtracting 2 from 1 and 3 from 2. But usually when you're talking about home values or increases in bank accounts or depreciation and things like that, you're typically talking about geometric series because values of things increase or decrease geometrically. So I would kind of default to, knowledge of that sort. Does that make sense? To you?
Yeah, that makes sense.
Okay. So I would automatically do something of the nature of do 190 divided by 190,962 divided by 185,400 and see what you come up with. That would be my launching point of this one. So some definite calculator work here. So I get 1.03 for that. And then you would want to take the 196 and divide this just to confirm. And you're going to really hope that it's the same since they gave it on a homework sheet. And it is. If you round, this one got a little deeper, but it's roughly the common ratio is 1.03. Deeper in decimals. At least that's what I got, unless I didn't type something correctly.
I got that too.
Okay. So we're looking at roughly the ratio of being 1.03. What I love about geometric series or geometric, when you're trying to find a value of a number in the sequence, it's so much easier because all you're doing is plugging in that first value, because it's a sub n equals a sub 1 times the ratio n minus 1. So that's all you're doing, really. So a sub n is equal to, what was the first year value? 185,400 times, and then our common ratio is 1.03. And then you've got n minus 1. So you're looking for the value at 30 years minus 1. So 30 minus 1 equals 29. So you're looking for 1.03 to the 29th value.
Okay.
So 1.03 raised to the 29th. I struggle with typing on the calculator, apparently.
I do too.
So I get like 2.356565 something.
Yes.
And then you multiply that by 185,400. So I get this number. And good for him. He needs to hang on to that house. That's what I got. What'd you get?
That's what I got.
Yay. Well, good. It always feels good when you get the same thing as the other person. So, okay. So the construction crew is pounding a stake into the ground. On the first stake, it goes 24 centimeters into the ground, 18 centimeters further on the second strike, then 13.5 centimeters further on the third strike. If this pattern continues, find the total distance the stake was driven after 7 strikes. So it doesn't look like it's arithmetic, because if it were arithmetic, if the first one is 6 less. And then it's like, what, 4.5 on the second. So let's see if I do 18 divided by 24, what do I get? .75. And so what do I get if I get 13.5 divided by 18? 0.75. So we've got a geometric series with a common ratio of 0.75. Does that make sense on how to do it?
Yes.
And did you see my process of like, okay, well, it's not going to be a common difference because subtracting looks odd. So then I kind of automatically jump to, oh, okay, it's got to be geometric.
Yes, that makes
Did that?
sense.
Okay. All right. So now I'm looking for the 7th strike. And this is going to be a summation because it goes 24 centimeters on the first strike. So you really want to, it says find the total distance. So if it went 24 here, 18 here, 13.5 here, you're looking for the total distance. So this is a summation because you want to add them all together.
Okay.
So how far down did it go? So you put in the value of the first strike, which was 24, and then 1 minus 0.75, which is my ratio, raised to the 7th power because it's asking after 7 strikes. And then at the bottom, it's 1 minus 0.75. And then this is calculator work, and I'm not always real good with instructing exactly how the So I'm going to take it one step at a time and do 0.75 raised to the 7th power. And then I'm going to do 1 minus that answer. And then I'm going to multiply that by 24. And then 1 minus 0.75 is 0.25. So then I'm going to take that answer and divide it by 0.25.
Okay, I got like 83 and then a bunch of decimals.
Me too. And if I rounded, it would be 83.19 centimeters.
Yes.
Is that what you got?
Yes, that's what I got.
Yay. All right, cool. All right, the table below shows the amount of snowfall for the first 3 days of January in the town of Orchid Hills. If this pattern continues, find the total, once again, total. That's the key word in these word problems. So to kind of distinguish of whether you're looking, for just a place in the sequence or if you're looking for the summation. Total amount of snowfall for the month of January. So if the pattern continues, it does look like it's going up by an exact amount each day, because you've got from here to here, that's 0.3 increase, and from here to here, it's a 0.3 increase. So it looks like it's arithmetic and with a common difference of 0.3. And there's a total number of days in January of 31. And the very first term is this one. So in the summation, I've got 31 times 0.2, which is the value of the first term. Then you want to figure out what the value of the 31st term is. So that's A31 equals 0.3, because that's the difference. And then N minus 1 is 31 minus 1, so that's going to be 30. Plus 0.02. So 0.3 times 30 is 9 plus 0.2. It's not 0.2 either. It's just 2. So that's 9.2. So this number here is 9.2, and that's all over 2.
Okay.
0.2 plus 9.2 divided by 2 times 31. I have 145.7 inches. What'd you get?
That's what I got.
Okay, good. Any other questions?
I think that's it. Thank you.
You're most welcome. Did that help?
Yes, that helped so much.
Okay, good. I'm so glad. Just email me if you have any other questions. Thank you so much for coming to Math Lab.
Thank you so much for helping me.
No problem. I hope you have a blessed day.
You too.
Bye-bye.
Bye.
Oh, hey, Bryson, do you have any questions? Oh, it's kind of staticky. You might have to text your question, because I can't really understand you. I'm sorry. Oh, great. I'm so glad that I took care of the questions. Nice violin playing yesterday, by the way.
Thank you.
No problem. And just email me or Miss Wynn if you have any further questions. Okay?
I will. Thank you.
You have a blessed day.
You too.
Bye-bye now.